Hello everybody, very happy to be in this workshop. My title today is Recent Advances in Trustworthy Federated Learning. Let's first look at a few application cases. Suppose we have several banks, and there are new applications to bank loans. As they come down from the bottom, a new user, this bank in the middle, is looking at the application and wishes to know whether this is a fraud case. One of the fraud cases happens when we have the applicant applying loans from multiple banks. Therefore, they can pay off on bank with a loan from another bank, and this creates a very high risk. So to prevent against this case, the bank in the middle wishes to verify with other banks whether this new user has applied for loans from their banks. However, the data at other banks cannot be sent to the bank in the middle because of user privacy and security. So how can this be done? How can the bank in the middle know whether the new user has applied for bank loans elsewhere without actually seeing the application data at other banks? So this is an anti-fraud case, which supports federated learning. With federated learning, we wish to support this application by not transferring any data outside of each bank, and yet being able to answer queries like this. A second case is when a bank wishes to build a richer model of a user. For example, the model will not only use a user's financial history but also other applications, such as tax payment, social network behavior and e-commerce. But again we face the problem. Each of these organizations on the right will not send any of its raw data to this bank. Yet the bank which knows the credit history will not know the necessary behavior information of the user at other places. So how do we enrich the user model? This is another question. So it reduces to we know the Y dimension, but we do not know the X dimension. The X dimension resides with other social media platforms. A similar situation happens when we wish to advertise to users. Say again, this is a bank which wishes to advertise only to a high potential user. So it's private. It's a personalized advertisement. But in order to advertise, the bank needs to know the user behavior information, and the social media platforms need to know the credit history of the user in order to know which ones are highly likely to respond to the advertisement. However, neither of them are permitted to transfer data to each other. How can this model be built, and yet the personalized advertisement be done to advertise to the user? And this is the third situation. The last one, which I used to motivate federated learning, happens in the medical domain where we have multiple hospitals. Here we have two hospitals. They each have their own data. And when a patient appears, we wish to use a global model to diagnose for the patient. The model should have the information from every one of these hospitals, not just this individual hospital. And yet we face the situation when we're not allowed to transfer data to each other. How do we build a global model without transferring data? This need is heightened by the recent media exposure of some high-profile cases, where we have seen in the Western media cases on Facebook, Google, Microsoft and others. And it's a high-stake situation. This is a heightened case, partly because the government are tightening legal regulations. Like in Europe, the famous GDPR is requiring that all the personalized data usage has to get permission from the individual users before applications. And cases such as Cambridge Analytica is well known, and is already made into a documentary on Netflix. In China, the situation is likewise tightened. In the government regulation last year, there were 3 major data security laws, including the Personal Data Privacy Protection Regulation, Data Security Law, and Cyber Casualty Law, all of which requiring that corporations and organizations cannot transfer their data containing user private information elsewhere. That's from the technology perspective. We are interested in developing a new paradigm for artificial intelligence, particularly for model building involving multiple parties. So federated machine learning or federated learning in multiple, in short, refers to when multiple parties try to compute a global model and use the global model and each party contributes some local data and information, and yet, we do not wish any local data to travel outside its perimeter, and we do not allow other parties to successfully infer any local information or any model information that are sensitive. So we can see an example shown here. This example involves, raising a model is like raising a sheep. Traditional ways to bring the grass to where the sheep is, and the grass information containing the grass is leaked out. A new way, federated learning way, is to lead the sheep to where the grass is, and protect the local information of each grass repository, data repository. And different ways to compute the global model have been developed, and the technologies are experiencing very rapid growth in recent years. The components of federated learning come from multiple disciplines, such as encryption, such as communication. So network communication, incentive building and economic mechanism design, and AI model and computation, and distributed machine learning. Okay, so multiple areas come together. The first version came out with what we call horizontal federated learning, and this is a situation where we have millions of Android phone users. These users, each phone has a lot of AI models operating in it, and they need to be updated frequently. The update will use local data. So for example, the typing model for a language model, which supports the next word computation in the Google typing software, or the face recognition software, they all require a constant update. But each phone holds local data that is highly sensitive. So the question is, how do we update the local model with so many phones, so many users' information? The horizontal federated learning method is to allow each local model to be computed, and the parameters of the local model is encrypted, and then the encrypted package is sent to a server, where the server computes a global model, without compromising the local encryption information without opening the package. And yet the global model can be built and distributed to the local, and the local model will then use the distributed updated global model to update its local information, which completes a local update. Using this way, each local model can be constantly updated, and the local information is not leaked out, because every step is very careful in protecting the transmitted information. The horizontal federated learning protects information with the consumer information. But when organizations work together, we call this business-to-business application. We have a complementing picture, where we have multiple parties sharing a lot of data features, and sharing user samples but not a lot of data features. So this is known as vertical federated learning, because different organizations are collaborating by vertically concatenating their data tables virtually, not in reality. Again, we require that the local information is not leaked out, and the local model information is not leaked out as well. And by saying leaked out, we do not allow other parties to successfully infer back any local information of any party. This is known as the vertical federated learning, and it's often used between banks and e-commerce companies, between hospitals, between government organizations that are business. Here's an example concerning multiple parties working together. So on the left, we have data stores from party 1 and 2, and they can each exchange some local parameter information, and allow both parties to grow its own model tree, while protecting the information of the local tree from the other party. And yet a global tree can be built. The global tree is completed when we have the local information put together. So when inference time, when a new user arrives at party 2 can ask a question about party 1 by encrypting the user's information, and send it to party 1. And when receiving that information, party 2 can continue its local computation and can produce inferred results, such as credit information, or user diagnosis information in hospital cases. On the right-hand side, we see a tree, a building process for two consumer applications. So let's say we have multiple edge devices such as phones, all of which holds a local tree. And putting them together we have a global forest, which can be updated using horizontal federated learning. Earlier I said, Federated learning is a multidisciplinary research, and there are many works in the economic theory and multi-agent theory on how to incentivize different parties to join an ecosystem. Here we see only one data owner will decide to join a federated learning global model if it's worthwhile. It's worthwhile when the benefit it receives is bigger than its costs. So therefore it can earn something, and what it earns is bigger than joining other ecosystems. One thing about federated learning building is, it's very important to define a security standard, so everybody follows this standard. If we don't have a standard, but we want to build a security system, a secure multi-party system, it's like drilling a hole in a mountain, which is very secure. People can find it very hard to attack, but maybe in 100 years we can build just one house. If you want to build something in scale, we have to use parts that are mass-produced and standardized. And by putting these parts together, it's like building a city and building a building. We had to follow some standard code regulation, and these codes are called Federated Learning Security Standards. Right now in international level and national level, we are building these standards. So federated learning has in recent years grown to be a very large community. Probably 4 years ago, there were a dozen papers each year worldwide, and now there are several thousand papers. So this was a workshop, organized by Google, which you can see there are many authors, from all different areas joining together, in building federated learning ecosystem. So here are some application examples. Even though federated learning is only a few years old, there are many large systems already in operation. The first one is in a credit system in the bank. Credit system used to be built by people, and they are very carefully crafted, and very simple, maybe a decision tree model. But today with digital economy, we have data from multiple sources, and all contributing to a global model. And this is the case when we have an ecosystem involving internet company, other fintech company data services, other banks, money lenders, e-commerce companies, and maybe government agencies, all contributing their data and models. And if you want to build a credit rating system to evaluate the security risk of a user, we have to use as many of these data sources as possible. And today, using federated learning, these parties can join the ecosystem without worrying that their data will be leaked out. And on the right-hand side we can see the blue line, which is with more data, the capability of the system increases in very fast rate. And we bank right now supports online services for 300 million users, 7 days a week, 24 hours a day, and 98% of the applications are supported by automated system like the AI system. With computer vision, a multiple construction sites can enjoy a better global model. A security camera application for ensuring the construction site safety, such as detecting fire, detecting smoking, detecting workers for lack of security helmet. And so the system is put to use in Shenzhen city. In e-commerce and advertisement application, a very widespread application is a user recommendation systems, which can enjoy multiple data sources to support very accurate, personalized recommendations of products. And today many of these data sources do not reach their data to be transferred out. So federated recommendation system is very useful and popular. One application of federated recommendation system is personalized news recommendation based on mobile phone. This is a real application in China, for a paid financial news application based on phone application, where we can see with more data sources involved, the page view reading time and click-through data all increase, which make the system more profitable and more useful, and users are happier with user experience. So beyond financial news recommendation, we also have medical applications. And here we have an application case with Tencent and several hospitals in Hubei province, where their local health checkup data are joined together. And a global model is used to diagnose the stroke early detection of stroke cases, and the cross-validation reveals that the improvement is great, to the point that the system is actually used for early screening of stroke patients. Some people are studying from academic perspective, whether when multiple parties work together, some parameter sharing between multiple parties can leak out some model information, which can further jeopardize the security of the local data. This indeed can happen when we don't protect the parameters shared between multiple parties, like on the right-hand side. And the left-hand side shows that, with zero character in a character recognition or OCR application, just by multiple influences on the parameter data, you can recover the local data from the other party. So different security methods are designed to prevent this from happening in federated learning. There are other cases which can further jeopardize the local information, such as using the generative adversarial networks, using other backdoor security information. And now there's a huge amount of academia and industry methods against these cases. One of the cases we design is against the Byzantine attacks, which are designed to by pretending to be a normal user. Their purpose is to destroy the model performance. We have designed several effective ways to detect and filter out these Byzantine users. And one of the methods we designed is using graph-based deep learning, which can find out the collaborative conspiracy users working as a clique, and they can be effectively ruled out. Earlier I mentioned that building standards are important, and here are several examples of international and national standards. The first international standard was laid by us, and it was published with IEEE in March 2021 last year. And this was the first international standard on defining the basic structure for the federated learning system working together. And there are many worldwide famous companies joining it. Today there are many standards within the financial industry, within the telecommunications industry, within different international and national standard organizations. As important as the standard, it is also important to have open source software to lower the entering barrier for application users. And we are the first to publish international well-known open source software called Fate. And Fate was donated to Linux Foundation. It is now used by more than 800 different enterprises. And there are many different societies and users contributing to the growth of the Fate system. Now Fate is the de facto international standard open source software, used in both academia and industry. Now just building the model itself is not enough, because we have to support the whole life cycle of federated learning. Recently we defined the term, Trustworthy Federated Learning, which involves not just in secure model building, but also in designing a system to protect the IP right of models. Our method is to embed a watermark within the model, so that the model parameters have the fingerprint of the owners. This is done especially for the deep neural networks where we can embed it. It's very hard to detect and very hard to remove, so that when multiple parties work together, we can use this to detect the adversaries and the free riders. So we designed a way to embed the private watermarks without hurting the performance, without reducing the performance of the original model. And we have a very easy way to detect where the model comes from, and who has been owning the model if it has transferred different hands. Federated learning has become an international phenomenon, to the point that the Gartner has recently added it to the height cycle of a Gartner curve. This curve shows which technology is being considered a rising star, and we can see federated learning is among them. Okay, so my talk stops here. Just to summarize, we know, with the growth of AI, data has become a problem, a challenge, particularly because we want to use data from multiple sources, and yet we have to protect data privacy and security. Federated learning is a way to solve this challenge by allowing different parties to work together without transferring out local data. And we have introduced horizontal, vertical and other styles of federated learning. And likewise I have introduced ecosystem standard, IP protection, and incentive mechanism, and different applications in areas. I wish to invite everybody to join the ecosystem to contribute to federated learning, which is a new paradigm for distributed artificial intelligence. Thank you very much.